All right, adding and subtracting rational expressions. So first we're going to talk about adding and subtracting fractions with like denominators. That just means that the denominators are the same. So step one, write a single fraction using the like denominator as the denominator. So that just means whatever the denominator was before for both of them, or all three of the fractions, we're going to have the same denominator. Okay. Number two, add or subtract the numerators depending on the symbol between them. Simplify the numerator. And the last step is factor the numerator and denominator if possible, and reduce. Divide out any common factors. Okay, let's do it. Okay, a plus 3 over 9 minus 7 over 9. The denominators are the same. So we're going to just write a single fraction, and the denominator is going to be our denominator, 9. And now we're going to write each of the numerators with the symbol between them. The symbol between them is a minus. So it's going to be a plus 3 minus 7. Now just be careful, because that minus sign, if the second fraction had more than one term in the numerator, you would have to distribute that minus sign. If it's a plus sign, you don't have to distribute a plus sign because it's going to be the same thing. But if it's a minus sign, be careful. You have to distribute the minus sign all the way through the numerator of the second fraction. Okay, so what we have here on this problem is a plus 3 minus 7. Now we can simplify. 3 minus 7 is negative 4, so we have a minus 4 over 9. We can't factor the numerator or the denominator, so that's it. Okay, this one looks like it probably is more interesting. So we're going to write a single fraction with 6x squared on the bottom in the denominator. And then what's going to go on top? Right, 3x minus 12. Can we factor? Yes, we could factor the numerator. What can we factor from the numerator? A 3. So factor out a 3, that gives you x minus 4. Now we could reduce. We could reduce that 3 and 6. 3 goes into 3 once, 3 goes into 6 twice. So now we have our final answer of x minus 4 over 2x squared. Okay, 4x plus 5 over 8 minus 2x plus 1 over 8. This is good. There's a minus in the middle, and the second fraction is a binomial. That means we're going to have to distribute that minus sign. Alright, so we're going to write our single fraction with an 8 on the bottom. And what you might want to do is put parentheses around the numerator to remind yourself that you have to distribute the negative sign. So put parentheses around the 2x plus 1. Now there's a negative sign in front of it. If you want to, you could put a 1 and then think of it as a negative 1 times both terms. Anyways, it'll give us 4x plus 5 minus 2x minus 1. Because negative 1 times 2x is negative 2x. And negative 1 times positive 1 is negative 1. Alright, so combine the numerators. What does that give us? 2x plus 4. Now we can factor. Factor out a 2 from the numerator. Plus 2 times x plus 2. And then we can reduce. The 2 and the 8 reduce. 1 and 4, so our answer is x plus 2 over 4. Okay, now we're going to talk about adding and subtracting fractions with unlike denominators. So cases where the denominators are different. First step is to find the LCD. The LCD is what both of them go into, right? So the lowest polynomial that contains the factors of each polynomial. Then we're going to multiply the numerator and denominator by the same factor, which makes the denominator equal to the LCD. So remember, whatever you do the bottom, you got to do the top. And we're trying to make the denominators match. Add or subtract the numerators and combine like terms. And then factor the numerator and divide out any common factors if any exist. A little bit of work here. Okay, here's our first problem. 3x over 16 minus 5 over 12. We need to find the LCD. So for 16 and 12, we're looking for the number that both of those divide evenly into. Not what goes into them, but what do they go into? Some people just multiply the two numbers at the bottom, but that gives you too big of a number. And then you have more factoring when you're done. So that's not a good plan. Anyway, so 16, one of the methods is to find multiples of the largest number. So there's 16, the largest number is 16, so multiples of 16 would be 16, 32, 48, 64, until you find a number that 12 goes into. And that number would be 48. Or you could find the prime factorization. So this is a method that's taught in arithmetic. You find the prime factorization of each number. And then the LCD contains each factor the most times it occurs in one row. So in this case, the 16 has 4 2's, the 12 has 2 2's. So we're going to take the 4 2's because the 16 had the most number of 2's. And then the 3, the most 3's is just 1 3 from the 12. So you multiply that out and that gives you 48. I have videos on LCDs if it's a little bit of a struggle for you. Okay, so we know what our LCD is. So now we want to make each of the denominators 48. So what are we going to have to do with the first fraction to make it into a 48? It's a 16. 16 times what number is 48? That would be 3. Whatever you do the bottom, you got to do the top. So the first fraction is 3. Now the 12. 12 times what number will be 48? That would be 4. 4 on the bottom, 4 on top. All right, so that's what we're doing. Now we're going to make it all one fraction, which is 48. And then 3 times 3x is 9. 5 times 4 is 20, so we have 9x minus 20. And you're all done. Nothing factors from the top. Nothing goes into both 9 and 20, so we're all done. If that were an 8x minus 20, then we could factor out a 4, but it's a 9, so that's it. Okay. 9 and 6. What's our LCD for 9 and 6? Yeah, 18. Again, you can do the same thing if you're having trouble. 9 is 3 times 3. 6 is 2 times 3. The most 2's in one row is just 1. There's only 1 2 in the bottom row. And then the most number of 3's in one row is 2, because there's 2 3's in the top row. Okay, so that's a process for finding the LCD. So that gives us 18. So what are we going to do to make each of them an 18? What does the first fraction need to make it an 18? 9 times what number is 18? Right, 2. So 2 on the bottom, 2 on top. Now because the numerator is a binomial, there's 2 terms, I think it's easier to put the 2 in front of each fraction because you're going to have to distribute. Okay, how about the second fraction? 3, right? 6 times 3 would be 18. So first fraction by 2, second fraction by 3, and then use parentheses to remind yourself to distribute. So 2 times 2x plus 1 over 9 minus 3 times 5x plus 2. The bottom will just be 18. So 4x plus 2 minus 15x minus 6. So that minus 6, that's where people make a mistake. It's not a 3, it's a negative 3 because there's a negative sign. If that was a plus sign in the middle, then it would be a positive 3. Okay, add like terms, that'll give you negative 11x minus 4. And there's nothing to factor from the numerator, so then we're all done. Okay, here's your next one. LCD is a little bit more complicated. Let's look at the numbers first. 3 and 2. What's the LCD for 3 and 2? Right, 6. In the variables, when you have a variable, you take the variable with the highest exponent. So the highest exponent is 2, so our LCD would be 6x squared. So for variables, it's the highest exponent. Okay, so we want to make each of them a 6x squared. So what are you going to multiply the first fraction by? A 2, but it also needs an x because it's only a 3x. So you're going to multiply the first fraction by 2x. How about the second fraction? It already has the x squared, but what does it not have? It doesn't have the 6. How about the third fraction? What are you going to multiply 2x by to make it a 6x squared? Right, a 3x. Okay, so there's our products with each of the fractions. LCD is going to be 6x squared. And we're going to multiply. Let's see, 5 times 2x, that's our 10x. 2 times 6, that's a 12. 3 times 3x is 9x. Add any like terms we have, the 10x and 9x. 19x minus 12, all over 6x squared. Nothing to factor out in the top, so that's it. If it were an 18x, then you could factor out a 6. But it's a 19. Nothing goes into 19 and 12, so we're done. Okay, here we go. Our denominators are binomials. And they're totally different, right? 2x minus 3, 3x minus 1. So our LCD is just going to be each factor. It's going to be 2x minus 3 and 3x minus 1. So when the factors are different, we simply multiply the factors to get our LCD. When I say multiply it, I just mean you write it as a multiplication problem. You don't have to FOIL or anything like that. Okay, so our LCD is going to be both 2x minus 3 and 3x minus 1. So whenever the factors are binomials and they don't factor, it's just going to be each one of those. Remember that we're trying to make the denominators match. So the first fraction has a 2x minus 3 in the denominator. We want to make it match the denominator from the second fraction. We want it to have the same factors. So it has a 2x minus 3, but we need to also have what the second fraction has, which is a 3x minus 1. How about the second fraction? It has a 3x minus 1, but we also want it to have a 2x minus 3. That way, if both denominators match, we could put the fractions together. Okay, so this first fraction needs a 3x minus 1. Whatever do the bottom, you do the top. The second fraction needs a 2x minus 3. Again, whatever you do to the bottom, you got to do the top. This time I put the two factors after the numerators because it's easier to distribute with the 3 in front of the binomial and the 2 in front of the binomial. Okay, so now distribute the 3 and distribute the 2. Wait, it's not a 2, right? It's a negative 2. So distribute the 3 and distribute the negative 2. Put that in the numerator, and the denominator will have 2x minus 3 and 3x minus 1. So it's 9x minus 3 minus 4x plus 6. Add the like terms, and then we're all done. 5x plus 3, nothing we can do with that. All right, example 8. 2 plus 4x over 3x minus 1. We want to make the denominators match. What's the denominator of the first fraction? Right, it's just a 1. Just a 1. So our LCD, well, 1 and 3x minus 1, the LCD would just be 3x minus 1. 1 times anything is still that anything. So our LCD is just the 3x minus 1. So the first fraction, that's going to need the 3x minus 1. And whatever you do the bottom, you got to do the top. The second fraction, that's not going to need anything. Okay, so on the first fraction, 3x minus 1 on top, 3x minus 1 on the bottom. On the second fraction, you could put a 1 if you want. You don't have to put anything. I just put a 1 just to show, like, hey, that's our anything. That's our 1, which gives you the same thing. All right, combine as one fraction. So 6x minus 2 plus 4x all over 3x minus 1. Add the like terms. Now you can factor out a 2 from the numerator, right? It'll give you 2 times 5x minus 1, but then nothing's going to cancel with the denominator. So you can leave it like that. If you want to write the numerator in factored form, you can. It's not wrong. Either one is correct. Okay, so now we're making it a little bit more complicated. To add or subtract fractions where the denominator is factorable, we have to add a step to the previous procedure. And here it is. Number 1, factor each denominator. And then number 2, then we continue the process given previously. So first thing is we got to do some factoring if possible. That's only the denominators. You do not have to factor the numerators, just the denominators. Okay, example 9. Is anything factorable? Yes, the first fraction, right? X squared minus 16. What does that factor to? Yeah, it's a difference of 2 squares. It's going to be x plus 4 and x minus 4. Okay, the second fraction stays the same. So we rewrote the problem with any denominator that can be factored. Okay, now we need to find our LCD. We want our denominators to match. Does the first fraction have anything that the second fraction has? No, the second fraction is an x minus 4. We have that. The first fraction has that, right? Remember, we're trying to make the denominators match. You're giving each denominator what it needs to make it match the other. Another way of saying it is it's each factor to the highest exponent. So it's an x plus 4 and an x minus 4. There's only one x plus 4, and each one has an x minus 4, but each of them have it only to the first power. Okay, so there's our LCD. What does the first fraction need? Nothing. How about the second fraction? What does the second fraction need? Right, it needs an x plus 4. So now distribute the 7. Oh, this time it is a positive 7, so you don't have to worry about distributing a negative sign. So it's 2x plus 7x plus 28 all over x plus 4, x minus 4, and then add the like terms. And that's it, we're all done. More complicated, right? This time both denominators can be factored. So that's our first step. Factor our denominators. How about the first fraction? X squared minus 36. Right, difference of two squares, x plus 6, x minus 6. Second denominator, 5x plus 30. We could factor out the GCF, which is 5. Okay, so now our LCD. Well, we only have one number. The one number is a 5. So the LCD is going to have a 5. And then we're going to need an x plus 6 and an x minus 6. Okay, so what does the first fraction need? It needs a 5. Yes, just a 5. How about the second fraction? What does it need? It needs an x minus 6 to make them match. So that 5 you could have put in front or after the 3x, didn't matter. The x minus 6, I would definitely put that after the 2. So now distribute. Let's see, the 5 times 3x, that's going to be 15x. And then distribute the 2. Oh, wait, not 2, negative 2. So 3x times 5 is 15x. Negative 2x plus 12. Add the like terms. 13x plus 12 over 5 times x plus 6, x minus 6. Okay, we're getting there. About 3 more problems. Yes, 3 more problems. Not too bad. All right, can we factor anything? Yes, that third fraction. So not only do we have 3 fractions, but one of them is factorable. Okay, so factor that third fraction. Our GCF is x. Okay, now our LCD. Let's see, we're going to need an x. The most x's is just 1, so it's just x. And then we're also going to need an x minus 2. So x and x minus 2. That covers everything, right? Okay, so the first fraction, that one needs an x. The second fraction, that one needs an x minus 2. And the third fraction doesn't need anything. Okay, put it all together. So 5x plus x minus 2, because we're distributing the 1, which is the same thing, then plus 2. The 2's cancel, so we get 6x over x times x minus 2. Oh, nice. On this one, the x's will cancel. So our answer is 6 over x minus 2. Nice, right? Okay, hang in there, 2 more problems. Okay, so is there any of these denominators, are there any of these denominators factorable? Right, the third one, right? X squared minus 1. What does that factor to? That's x minus 1 times x plus 1. So now our LCD. Well, let's see. We're going to need an x minus 1 and an x plus 1. Anything else? No, that's it. So what does the first fraction need? It needs an x plus 1. How about the second fraction? An x minus 1. How about the third fraction? Nothing. So first fraction, x plus 1. Second fraction, x minus 1. Third fraction, nothing. Put it all together. So distribute the 4x, the negative 2. So 4x squared plus 4x minus 2x plus 2 minus 4. Add like terms. Let's see, 4x minus 2x, that's a 2x, and 2 minus 4 is negative 2. So 4x squared plus 2x minus 2. Now on the top, we could factor. First of all, there's a GCF, so factor out a 2 on the top. And then that trinomial, you could factor that. I don't have room to show, but 2 times negative 1 is negative 2. There's 1 and 2. You might want to do that on scratch paper. So the numerator factors to 2x minus 1 times x plus 1. And then keep that 2 in front. And then can anything cancel? Yeah, the x plus 1s can cancel. And we're done. 2 times 2x minus 1 all over x minus 1. I don't know why we put parentheses around the x minus 1. You don't have to put the parentheses around the denominator. Not wrong, just unnecessary. All right, last problem. Again, we've got a factor. I know I go through this kind of quickly, so you always want to pause the video and work out these problems on your own. Okay, so the first fraction, the denominator is a minus 9, a plus 6. And the second one is a plus 6, a minus 1. LCD, let's see, we're going to need an a minus 9, an a plus 6. Anything else? Right, an a minus 1. That covers everything. So what does the first fraction need? It needs an a minus 1. What does the second fraction need? It needs an a minus 9. So what we're doing is we're changing each expression to an equivalent fraction with the LCD as the denominator. So we're making it happen. We're making the denominators match. Whatever do the bottom, you need to do the top. Distribute the 6. Distribute the negative 10. (6a minus 6 minus 10a plus 90). Add the like terms. That should give you negative 4a plus 84 all over a minus 9, a plus 6, a minus 1. We can factor out a negative 4 from the numerator, but that'll give you an a minus 21. And then that won't cancel with the denominator, any fraction in the denominator. If it was like a negative 4a plus 36, okay, then maybe something cancels. But this is it. All right, we made it through another video. I'll see you here for the next one.